Hello, this is Peter from Educom Mondo and a warm welcome to our STEAM project number 14 called The Counter. These lessons are for the absolute beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. Today we will program a 4-digit 7-segment display as a counter. The goal is to add 1 at each push of the up button or to subtract 1 when pushing the down button. Before starting with this project, make sure that your class understands the principles of the single-digit 7-segment display from lesson 13. We will practice the use of the library sevseg.h. We will install 2 push buttons in a rather complex project to build. And last but not least, we will encourage teamwork in your classroom to be successful. Let's take a closer look at the 4-digit 7-segment display. With the 7 segments, the numbers 0 to 9 can be created. The different digits represent the thousands, hundreds, tens, and ones. The largest number that can be displayed is 9,999. There is also an 8th segment representing a decimal point. There are 12 pins coming out from the back of the display, grouped in parts of 6. Let's draw on the whiteboard how these pins are related to the LEDs of the display. In the 4-digit 7-segment display, there is 1 pin where all A segments are connected, 1 pin on which all B segments are connected, 1 pin for all C segments, and so on. And next, there is 1 pin per digit, pins D1 till D4. Now we need to understand which pin is doing what. At first sight, this is a bit confusing, as there is no apparent logical sequence. Let us work with an example to explain the working of the 4-digit 7-segment display. How is it possible to light up, at the same time, on all 4 digits, the segments B and C to form the number 1111? The answer lies, unfortunately, in the slow reaction of our brain and our eyes. The microcontroller will first light up segments B and C in digit 1 and switch them off again. Then switch on the segments B and C on digit 2 and off again. The same for digits 3 and 4. As long as this happens faster than 60 times per second, our eyes and brain will not notice this fast on and off switching and will interpret this as a continuous display of the number 1111. This method is called multiplexing. And this is also the reason why we only need 12 pins to control the 4-digit 7-segment display. Now that we understand the working of the display, let's distribute the components to our class. The microcontroller and the breadboard, the 7-segment 4-digit display, 8 resistors of 220 ohm, 2 push buttons, one will be the up button and the other the down button, 2 pull-up resistors of 10,000 ohm, 16 jumper cables, and quite a number of short and long preformed wires. Let us take a look at this schematic representation of the project. Arduino is supported by a large group of enthusiasts, and there is a vibrant forum where you can find answers or post new questions. We have found this schematic on the forum made by user Golem Mostafa. You can keep this projected on a wall or on your screen to make it easier for your students to refer to. As you can see, the final project is quite complex, which means that your students have plenty of opportunity to make mistakes. In order to speed up the video, we will go over the different components step by step. The center of the project is the 4-digit display. The segments A through the decimal point are connected via 220 ohm resistors to the digital pins 3 through 9. We have used a large display, so the space on the breadboard is quite tight. You can see that we used preformed wires to create some room to connect the resistors to the display pins and to the digital pins on the Arduino. Next, we connect the display pins D1 to D4 to the digital pins 10, 11, 12, and 13. We do not recommend the use of the digital pins 0 and 1, as these are used by the Arduino itself to upload your sketch. You can see that these pins are labeled RX and TX, short for receiving and transmitting. Luckily, on the Arduino, we can use the analog pins as digital pins. We connect the up button to pin A1 and the down button to pin A2. Here you can pause for a moment to check if your class still remembers how to install the pull-up resistors. If not, let them revisit lesson number 10, the desk lamp. The button legs that are curled towards each other are connected. The other legs are not connected until you push the button and close the circuit. One leg of the button is connected to the ground. The other leg is connected via the pull-up resistor to the positive voltage provided by the microcontroller. We capture the signal of the button between the push button and the pull-up resistor and lead this to the analog pins A1 and A2. Finally, we connect the 5-volt supply and ground of the Arduino, and thus finishing our project. Now is the time to start programming. Ask your students to connect the microcontroller to their computers and let them open the Arduino integrated development environment. Add at the top the name of your new project, Project 14, the counter. And this is also the place to declare the variables. We start by including the library cevsec.h, and as we have seen in the previous lesson, we will refer to cevsec as S. We also define the two arrays that are needed within the library. One is called common pins and the other one is called seg pins. The common pins, we use the digital pins 13, 12, 11 and 10. And the seg pins are the segment pins, so 2 through 9. We will also need a variable j, which we set to 0. At this stage, we will also define a delay variable at 100 milliseconds. In this area, we also need to declare our buttons. So one is called button up, and the other one is called button down. Thus, the purpose of this project is to increase or decrease a variable number j with 1, depending on which button we push. We also need to define the following variables. A variable to reflect the increase in value, and a variable to reflect the decrease in value. We will also declare two other variables called the increase previous or incprev and decrease or decrease previous decprev. We will explain later in the code why we are introducing these new integers. For now, let's just declare them. S.begin, we have a common cathode, four digits, followed by the arrays common pins and seg pins, and yes, we are using resistors. In the setup area, we also declare the analog pins A1 and A2 as input pins, since they will be captured the high or low signal from the push button. And we do that by now our very well-known command pin mode. In the loop section, we define the variables INC and DEC. INC, or short for increment, is the digital read of the push button up. And similarly, DEC, short for decrement, is the digital read of the push button down. In the next section, we have to program what this up or down signal will do. Let's first look at the increment. So if the increment variable is equal to low, and our variable j is smaller than or equal to 9,999, what will happen? Well, j will be set equal to j plus 1. So we will add 1 to the counter. Note that we compare the variable inc with a low state because we are using pull-up resistors, and we know that with a low state the pin is on. Now we do the same with the decrement. So if our decrement variable is equal to low and our variable count is larger than or equal to 0, then what do? We say that j is equal to j minus 1. So we subtract 1 from j. And then we use the functions s.setNumber of our variable j and also the function s.refreshDisplay. Let us upload the code and see what is happening. The variable j is set to the start value of 0, so that seems to be okay, but when we push a button, you see that a seemingly random number is displayed. It is certainly not counting with ones. Ask your students if they might know what the reason is. The reason is that the Arduino is too fast. When we push the button, the pins A1 or A2 don't get one single impulse, but tens, if not hundreds, in the short time span that the button is pushed. The result is this seemingly random number on the display. So we have to go back to our Arduino IDE and tell the Arduino that only one impulse has to be taken into account. In other words, we need to tell the Arduino program to ignore a second pulse. And we do that by adding another condition that says "n" and the variable inc is different from the previous inc value. As such, only one value will be sent once to the Arduino pin A1 when pushing the button. We will also add our delay of 100 milliseconds to allow the push button some time to do its work. And we do the same for the decrement. The decrement variable has to be different from the previous value. Let your class upload the code again. And this time, nothing happens when we push the button. Time again for your students to discuss what is going on this time. And what they need to do is to reset the inc previous to inc again. So we need to add 2 lines of code, inc previous equals to inc and dec previous equals to dec. That will get us into the correct logical loop. So when we push the up button once, and even if we don't release it, the counter will add a 1 to the displayed number j. When pushing the down button, the variable j will be decremented with the value of 1. This concludes our project number 14, the counter. What did we learn? Well, we now understand the workings of the 4-digit 7-segment display. We practiced the use of the sevsec library. We programmed push buttons on a rather complex project. And the most important, we encouraged teamwork to be successful. Counters are used to count things that come or go from a certain location. This project is great fun for an outdoor assignment. You can divide your class in several groups to count the number of cars, bicycles, motorcycles, and pedestrians that pass in one or other direction on the street during 10 minutes. Let the group calculate how many there were by the hour. You can compare the results of the two directions. Is there a difference, and can you find a reason why? Or maybe your class can visit a small farm and you can ask them to count the different types of animals. Compare the results of the different groups and let them calculate the averages and the mean of their measurements. These are just some suggestions. You can use your own imagination and experience to assign fun tasks to your class. But when going outside the school, remind them to be careful. I hope that you and your class enjoyed this project and that you are eager to start with project number 15. In that lesson, we will work with an 8x8 LED display, creating the image of a beating heart. Bye bye for now, and looking forward to meet you again in our next lesson.